Good day, everyone. In our previous lecture, we looked at the different flight controllers that are present in the market. Now, based on the available flight controllers, what are the factors for selecting a flight controller? In our present lecture, let us look at the factors which decide on which flight controller to select for our drone. Let's go in detail from our next slide. Let's start with understanding the factors that decide on which flight controller to select. Some of the factors are as follows. Factors, these factors are as follows: affordability, open source firmware, autonomous functionality, microcontroller based environment, popularity, and processor. Let us look at in detail these factors which decide the selection of the flight controllers. Flight controllers are continuously evolving with their processors, becoming faster to keep up with evolving flight control softwares. Flight controllers are usually titled to include the main microprocessors, usually an STM Electronics 32-bit microprocessor model, as this gives the pilot a basic idea of the flight control capabilities. The most common microprocessor modules used are the STM32 F1, F3, F4, and F7 chips. Essentially, the higher the number after the F, the faster the microprocessor will be, and the more functionality it will have. For any pilot purchasing a flight controller, it is currently recommended to purchase one with an F4 or an F7 processor, as they are easily fast enough to run the latest FC firmwares. F1 processor is the oldest processor and has the lowest processing capability of all the above processors. It is actually an outdated processor with Betaflight ending support to F1 FCs in 2017. F3 was essentially an F1 FC with increased number of UARTs and increased flash memory. Some smaller FCs use this processor even now because of their compact size and exceptional processing power. F4 was a giant leap in mini-quad processors with more than double the processing power than that of an F3. But there are limitations with F4 processors with no support for smart audio natively, which is not a big deal for most people. Still, F4 FCs are the most popular choice for their functionality and affordability. F7 processor is the big daddy of mini quad FCs. F7 FCs became available mid of 2018, and these are the most recent processors. F7 FCs are packed with up to 8 UARTs, which can be used for telemetry, GPS, camera control, etc. F7 FCs come with a dual gyros, MPU 6000, which is noise resistant, and ICM 2062, which can run 32K gyro sampling. To program a drone flight controller, it is connected via micro USB to the computer and flashed with a firmware specific to the chosen FC configurator software. The firmware configures the board with the program and settings required to manage and control the quadcopter. The USB interface allows connection between the FC and its configurator, enabling the user to modify and change the board settings, including the rates, PIDs, receiver configurations, fail-safe setup, and flight modes. For all FCs, it is recommended to flash the latest firmware available, as it will usually have improved flight characteristics and a reduced quantity of software issues. An FC can be flashed with firmware for use with the configurator, example Betaflight, CleanFlight, and occasionally RaceFlight. All configurators have specific benefits to them, and an individual preferred configuration is subjective. As a general recommendation, use RaceFlight or KISS with your flight controller if it is listed as compatible. Otherwise, use Betaflight, which is the most common configurator, as its open source nature provides compatibility with most FCs. A drone flight controller is mounted to a drone frame using four equally spaced mounting holes. Currently, 30.5 mm by 30.5 mm spacing between hole diameters is the standard on a 220 sized quadcopter. 20 mm by 20 mm spacing is also quite common on a 70 to 130 size quadcopters. The mounting holes are usually 3 mm diameter. Smaller mounting patterns also exist, although they are used most exclusively for sub 70 mm quadcopters. Many flight controllers actually use mounting holes larger than 3 mm diameter to allow insertion of the rubber grommets which assist in isolating the FC from motor vibration. In regards to connecting external components to the FP, to the drone flight controller, they can be purchased with solder pads, pin header holes, plugs, or a combination of the three. Solder pads are the most useful, compact, and preferred connection as it allows neat low profile external componentry connections to be made. Pin header holes are also common on FCs, although they reduce weight and connection profiles. Pilots will usually solder wires directly to the holes rather than soldering on header pins and connecting wires using a servo plug. Lugs are not the most prevalent FC connection method, although they allow external components to be quickly disconnected. Due to motor vibrations, thin soldered wires can eventually fray and snap off from solder pads or pinholes. To prevent this, hot gluing solder joints is a safe option to prevent loss of circuitry during flight. Solder pad FCs are recommended for most applications. However, the use of connectors can also be useful for small, tight, or modular setups. UARTs stand for Universal Asynchronous Receiver Transmitter. UART is a hardware interface that allows the user to connect multiple devices such as camera control, VTX channel control, serial radio receiver, etc. UART has two ports to transmit and receive data. A FC may have TX4 and RX4, where TX4 stands for UART4 transmitter and RX4 stands for UART4 receiver. Prior to 2014, FCs used to have up to 20 UARTs on F, where people need not worry about running out of UART ports, as manufacturers wanted to miniaturize FCs, which they did, was at the expense of lesser number of UARTs, with 8 being the most number of UARTs found on a modern day F7 FC. If you plan to run telemetry or small port or even GPS for a long range and a whole lot of other peripherals that may require UARTs, you are going to have a hard time finding UART ports. You have to prioritize your peripherals and choose accordingly. On-screen display. The function of an on-screen display chip is to overlay information from various sensors and display parameters such as battery voltage, current consumption, GPS location, altitude, etc. This information gets transmitted via the video feed from your camera. Betaflight OSD has features that a FC can be programmed to display like an artificial horizon, display airspeed, GPS coordinates, current consumption, and amperage consumption, and so on. Below is a list where in the front of you can see how the OSD actually looks like, where you can see the various overlay on the screen of this drone. FC manufacturers wanted something unique to sell more of their products, and PDB integrated FCs are the result of their venture. Through PDBs on FCs eliminate the need for an external PDB, it also reduces the height of the stack by up to 15 mm. FC's integrated PDBs are ideal for frames with tight spaces, but they come with their own set of challenges and disadvantages. Even though these FCs reduce the height of the stack, they are prone to electrical noise interfering with the gyro. As the current flow is very close to the flight control processors and gyros, voltage spikes and electrical and magnetic interference may cause some issues. That being said, manufacturers claim that they are well isolated from the electrical noise. Black box is something similar to that found on airplanes, where all the data from the quad is stored. This black box data is stored in the SD card, which we plug in the slot. Black box is something similar to that found on airplanes, where all the data from the quad is stored. This black box data is stored in the SD card, which we plug in the slot. Black box helps to analyze data of every parameter, such as voltage draw, current consumption, and so on, such that they can be analyzed later on the ground. If any oscillations or vibrations are noticeable, then the black box data can be fed to PID analyzers to identify the necessary corrections and tune your quad. To summarize, we looked at the factors deciding the selection of controllers, the flight controller processors, the firmware, hardware, the UART's availability, on-screen display, power distribution board, and the black box. In our next lecture, let us talk about the most frequently used flight controllers based on various applications. This will help us a lot while selecting our own flight controllers based on the kind of applications. Thank you very much.